velocity time graph. You look at the vertical axis here. They say mile per hour. Mile per hour is the velocity. Then if you look at the horizontal axis, is this stated here? Time, right? So it's
Okay.
velocity versus time. So everything that you learn about velocity versus time, you must recall. Recall what you have learned about velocity time graph. And the first thing you recall is the slope is the acceleration. Area under the graph is the displacement, right?
Okay.
So you read this example, a velocity versus time graph from here. You read
Um,
a velocity versus time graph.
Slope of tangent equal acceleration. Area under the graph equals displacement. Do
Okay.
I continue the questions
The
or
question, correct.
A? Describe the motion of acceleration. Find the peak acceleration of the acceleration in the miles per hour per second as the train speed up to 45 miles an hour to 70 miles an hour. Find the train's displacement in miles between t equals 0 and t equals 200 seconds. Find the average acceleration of the acceleration and its displacement in miles in the interval from 200 seconds to 300 seconds. The train has regenerative braking, which means that it feeds energy back into the utility lines each time it stops. Find the total displacement in the interval from 0 to 400 seconds. Note, assume that all quantities and estimates are good to two significant figures. Estimate by different individuals may vary and result in slightly different answers.
Okay, right. So now the first part is what you should do is you look at this graph here and explain what is happening. It means that you have to tell them what you can see. The things that you cannot see, like slope and area, that will be the later part. That will be the later part. So the first part, just tell them what you can see. Right? You tell them what you can see. Okay,
Okay.
right. So I have enlarged the graph and put it here. Okay. So the motion is from the time -50
Mm,
until 400 seconds. From 0 until 50, right? Roughly they are along a flat straight line. Okay.
yeah.
So I break it up into this point right here. Okay, I break it up here. So the first part of the journey is this. Okay, from -50 until this green line here, until this green line, right? So it is actually flat. Flat means the velocity is 50 mile per hour, 50 mile per hour, 50 mile per hour, right?
Uh-huh.
So it means that it's traveling with constant velocity,
Yeah.
constant velocity. So that is what I have written here. Okay, where is it? Okay, this one. So this is the first part here. From -50 to approximately 25 second, the train move with constant velocity. Or also because the velocity is positive, so it's moving in the positive direction. Okay. Now the next part of the journey is this one. So, right? This part here, from here to here.
Okay.
So from here to here, it is a slope, but it's not very steep. It curve upwards like this. So curve
Okay.
upward means the velocity it has increased already. It's no longer constant flat like that. So the velocity has increased, but it is not very steep. So it's this part. So from 25 to 50 second, it accelerates.
Okay.
Okay. Next part. Next part from 50 to 100 here. From this line, 50 until 100 here. So during this period of time, it will be from this black dot here until the other black dot here. So actually the velocity is increasing and it is quite steep. The line is quite steep. So generally from 50 to 200, it is accelerating, right? It is accelerating. From 50 to 200, it is accelerating. Where is 50? 50 until 200. You see the velocity going higher and higher and higher, right? So in general, it is
Yes.
accelerating. But in particular for this 50 to 100, 50 to 100 is very steep. So I say 50 to 100, it is accelerate. Then from 100 to roughly 180, this part here, this part here.
Okay.
From 100 to 180, it is not so steep anymore. It is less steep. This part, this part is very steep, then this part is less steep. So it's still accelerating. It is still accelerating, but not so fast. And the velocity peak during this s equals to 180. That means from 100 to 180, it will keep increasing until the maximum here, until the maximum velocity here, right? But if you compare this part of the journey to the previous part, although it is accelerating, but it's not so great anymore. It is not so steep anymore. Then from 180 to 200, you see that there's a drop. 180 is at the peak, then 200 it drops out. So from 180 to 200, they start to decelerate. They start to decelerate.
Okay.
So I have divided the journey into, you see the green color, I label the period green color here, green color here, green color here,
Mm-hmm.
and green color here. All this green color shows that the velocity is increasing, but at different rates, at different rates. Very steep means very fast. Less steep means it is increasing, but not so steep.
Okay.
No, after this 180, they start to drop down, right? Start to drop down, so you start to decelerate. I begin to label them with blue color. I label them with blue color, right? So
Okay.
from 200 onwards, from 200, 200 to 250, 250 to 300, and so on, they keep dropping. So I say 200, 200, 250 decelerate. 250 to 300 also decelerate.
Yep.
300 to 350 also decelerate. They decelerate at different rates. This one is steeper, this one is less steep, and this one is even lesser. It's almost flat already. From 300 to 350, it is almost flat. And when it reaches 350, it is exactly at the x-axis. So I say the velocity reaches zero, right? From 300 to
Mm-hmm.
350, decelerate until the velocity reaches zero.
Okay.
Okay. From 350 to 400, 350 to 400. You see, at first the velocity is zero, and finally it becomes negative 50. 0 to negative 50. Accelerating or not accelerating. Starting, the time is not moving 0. Finally, it is moving at negative 50. Accelerating or not accelerating?
Okay.
It is accelerating.
Uh. Yeah.
Because at first it is 0, finally it is negative 50. So it is accelerating. But this time, the acceleration is in the opposite direction because the velocity is negative. So it is accelerating in the negative direction. Okay,
Mm-hmm.
you you remember you remember the other one, huh? Where is the other one? I think it's this one. Yes, this one, right? Okay. So you remember this negative velocity, but it is increasing, the velocity is increasing, but it's in the
Okay.
negative direction, right? So this is the same as just now here, over here, this part, right? The velocity is increasing, but increasing in the negative direction. If you calculate the slope will be negative, but it doesn't mean that it is decelerating. It means that it is accelerating. Okay, the second one, find the peak acceleration